I would like to greet everyone. My name is Holger Krohmer. I represent Becker mining system from Saarbrücken, from Germany. Unfortunately, I have only 10 minutes, so let us start then. So we have our exhibition booth. You can come after the presentation to us and to receive more information. Thank you so much. I want to thank all the organizers for this event. One of our competences is digitalization of the underground ores, and I would like to present you our Smartflow solution that help us to work with this. So people say that if you stop digitizing, you go to the bottom. But in our case, we have a very different situation. You know, our company, let's say, was born underground and started to digitalize from over there. We are living and we are breathing with the mining. We produce first-class, easy-to-integrate, highly reliable and high-quality infrastructure products for mine. And we are leading in environmentally friendly mining technology. Becker is a family enterprise that was founded in 1964 by Walter Becker. Franz Becker developed it till the current status of the world level. Jonas Maximilian Becker moved the company to the next level of the development, and this year we are celebrating our 60th anniversary. The company or the products of Becker is represented in more than 100 countries. We have the production facilities in Poland, Canada, Mexico, South Africa, Australia, US. We also have representative office in China and in Russia. So here on this slide you can see just some of the largest mining enterprises that use our technologies, Becker technologies, and this is our long-term and mutually beneficial partnership. The technologies that have been developed by us ensure maximum safety and efficiency in the extraction of natural resources. We adhere to the principle of zero harm, both for humans, for our employees, and for the environment. We are one of the leaders in the development of digital technologies for green energy. The principles that guide us in the development of our products are saving resources, increasing the life cycle and modularity of our equipment, quality, reliability, and performance of the equipment. The key feature of Becker technology is a technology that is integrated and assembled on a single platform. This platform connects and manages all our entire product range in 3 different level networks, so-called backbone. Leaky feeder, this is a cable antenna system based on UHF technologies, and also we have the Wi-Fi technology with fiber optic network as backbone, which allows us the transmission and processing of more significant data. And the third foundation for networks is our LTE, the third generation mobile radio standard. The main and central element or the heart of our system of control and management, this is our software, which is called Smartflow. On mobile radio standard in the mining sector, we have a long-term partnership with Ericsson. LTE offers a path to smart mining and a future with greater safety, profitability, and environmental responsibility. Due to the high level of connectivity, all our machines or equipment could be remotely controlled, especially in the specific areas. For example, we might not send employees to the dangerous work because all of this could happen in a remote mode. Becker is built on 5 key pillars. So here we speak about power distribution, especially for explosion protected areas, power centers, transformers, cabinets, automation, control, for example, conveyor control, environmental control, software, communications, IP telephony, IP telephone communication, PDS, proximity detection system, personal transportation. So here we represent rail, transport, monorails, ropeways for underground, personal transportation, different type of skip winches, conveyor winches, pumps, ventilation, mine support infrastructure, which includes hydro-mechanized supports, coal crushing equipment, armored conveyors, and some other arc profiles for underground supports. Here you can see fully automated mining process underground and on the surface, and as for the specific surfaces, so here you can see all the equipment that we, Becker mining system, built and develop and supply. Smartflow is a system that would unite newest technological solutions. So they are based on identification of all operational flow, and all of this can be done in a real time, as well as integrated with communication network, monitoring and signaling. The concentration of information in a single system facilitates continuous improvement, optimization of production process and increased safety level, thus becoming the manager for more sustainable development. As for the modules that Smartflow serves in our range, we have tagging and tracking. The tagging for tracking. We have telemetry, which is monitoring and identification of all work processes in our machines, collision prevention. We also have collision warning, power monitoring, gas monitoring, ventilation monitoring. Here you can see our telemetry module. The module collects, compares and transmits all the important information about the equipment, and it could be available for all mining and construction equipment, both for surface and underground. So tracking could be conducted with regard to the equipment status online, so that quick action to correct or to prevent malfunctions would be made. This improves preventive maintenance planning through the condition monitoring, and here we also speak about improving the equipment utilization and its productivity. The tracking module and identification of location. This is the basic and an important part of our Smartflow. We have 3D observation. You can find here the recording of the personnel, of all mobile equipment that is underground. The ease of interaction and motion graphs allow intuitive, convenient and easy to use software. Benefits. We also see here the control over the personnel or employees, not only control but also location of people. It means safe works. Next module is this system of collision prevention. So this is also done in a real time, very specific and accurate positioning of all the vehicles and personnel. This module could be used as both on the surface and on the ground. It integrates on both light and heavy vehicles and trucks, and is designed to alert the vehicle operator at all times when people or machinery are approaching to it. Here on the slide you can find my contact details, and if there are any questions you also can come to our exhibition stand or booth and ask any questions that you want. Thank you so much for your attention.
I'd like to invite the Andy Post from Naue. Please take your place at the stage.
Thank you for the kind introduction. Ladies and gentlemen, it's really my pleasure to be for the first time in Kazakhstan and right away to present at this well distinguished show. My name is Andy Post, and I would like to talk to you today about safe, innovative, sustainable geosynthetic solutions for the mining industry, especially with regard to, let's say, advantages of our new Plus products. Naue, just to explain shortly, is a company with a headquarters in Germany. It's a family-owned business and with production facilities mainly in Germany and Southeast Asia. Let's say usually we all know this in the mining industry. We have to deal with huge sites, maybe aggressive leachate, probably massive loads. We can face drastic consequences, especially with regard to, let's say, failures in the of tailings facilities, and we face, let's say, manifold challenges on the site or off the site. Therefore, let's say, I would like to show you one project, one case study. It's a gold mine in Greece that we supplied several years ago. It's a dry stack tailings facility. 2 to 3 weeks ago, I was in Jakarta. Let's say we organized a dry stack a seminar there, and I have, let's say, the impression that, let's say, globally, let's say we will move, let's say, from slurry, from wet tailings, more and more towards dry stack tailings facilities, because, let's say, in the end, they are just, let's say, safer. With regard to this project, we faced mainly 3 challenges. Let's say the toxicity of the tailings, let's say challenges with regard to geotechnical stability, and let's say waste rock disposals. Here, let's say, you can see, let's say, the materials that we, let's say, applied and supplied there. Let's say from, let's say, bottom to top first. Let's say we had a so-called geosynthetic clay liner. Let's say followed by a geomembrane. That's a, let's say, that's a composite lining system, and on top, let's say, drainage materials and geotextiles. This is a pretty nice aerial picture, and here you can see, no, it's not working. Let's say the brown surface, that's the geosynthetic clay liner. The black one is the geomembrane, and the white, let's say the protection geotextile. We basically let's say, have so let's say 3D graphics of almost all mining applications available for tailings ponds, baselining, capping, extension of tailings ponds, and all of that. In case you are interested, please visit our website or contact me after the presentation. Let's say a few slides with regard to, let's say, the requirement, let's say the guidelines with regard to the products. If we talk of geomembranes, then let's say the international standard would be, let's say, the GM13 standard, and with regard to geosynthetic clay liners, it's the GRI GCL3. That's American standards, but not sure if you remember, let's say, those cars. Let's say the blue one, that was, so to speak, the one-size-fits-all car for almost everyone, let's say, in the east part of Germany before, let's say, our reunification. But fortunately now, let's say, we have the choice. Yeah, we can choose if you would like to buy an electric one. We can choose the color, the size, the tires, and so on. And our approach, so to speak, let's say, in the technically is the same. Yeah, let's say let's say our approach is that we cannot apply and sell the same materials for all conditions. Yeah, therefore we have, for example, different sealing materials, so geomembranes, Carbofol, geosynthetic clay liners, Bentofix, and even, let's say, a product so in between. So our approach is that we would like to have the choice. We all would like to have the choice in life, not only with regard to cars, but also, let's say, in a technical sense with regard to, let's say, the requirements on site. Yeah? So we would like to tailor and select the materials according to the project-related requirements. In this regard, I would like to mention shortly our, let's say, newest development. We call those products the Plus range, yeah, because, let's say, we can face conditions, let's say, aggressive leachates, elevated temperatures, or, let's say, exposed, let's say, liners, and all those conditions, let's say, will attack the lifetime of geosynthetics. They mainly have two enemies. Let's say one is UV and the other one is oxygen. Yeah. So and we identified, let's say, a recipe. Yeah. Let's say to enhance the lifetime of these products in case we face really, let's say, harsh conditions on site. I don't want to go into details. That's, let's say, a science in itself. In case you are interested, let's say, we have the opportunity to talk later or tomorrow or this evening. Or let's say we have, let's say, a technical note available with regard to those products. Again, please cast a glance on our website or ask me, let's say, after the presentation. This is a, let's say, sustainability session. So I would like to focus on, let's say, this side as well. So if we compare, for example, clay versus geosynthetic clay liner, yeah, and if we look at the surface of, let's say, 400,000 squares, that's not a big surface with regard to, let's say, heap leach pads or tailings. Yeah, if you well, in case you have the clay available, even then you need 19 million, more than 19 million liters of water to install this clay, yeah, compared to 0 if you utilize a geosynthetic clay liner. Yeah, with regard to the construction time, you need almost 200 days to, let's say, install the clay versus half of the time with regard to the geosynthetic solution. With regard to transportation, let's say with regard to a surface of only a bit less than 5,000 squares, let's say we can transport, let's say, the needed geosynthetic clay liner in one truck. Yeah. You need almost 200 trucks to, let's say, transport the clay to site. Yeah, and then if you think that, let's say, the surfaces that we deal, I mentioned it right at the beginning, we deal with huge sites. 400,000 squares or 1 million or even more. Just imagine what you can save just in this case if you utilize geosynthetic clay liners instead of clay. Yeah, you are now almost on the home straight. Of course, let's move away from those sealing applications. Of course, we all know there are many other structures on the mine and off the mine that we have to deal with, construct. For example, let's say crusher walls, loading ramps, and all of that. And again, this can be done utilizing a geosynthetic solution. So in this case, if you compare, for example, a reinforced wall compared to a concrete one, you can, let's say, save 30% in construction time, 50% with regard to the costs, and almost 80% with regard to the energy demand or CO2 emissions. Yeah? So also with regard to reinforcement and stabilization, yeah, there are smart, let's say, solutions available utilizing geosynthetics. Another one would be pole roads, of course. Yeah, again, here are geosynthetic solutions available, and you can, let's say, on the maintenance side, you can really save a lot of money. In case you work with geogrids instead of, let's say, increase the height of your quality engineered fill. So, the final message is, let's say, geosynthetics. That's still a niche industry, but relatively smart materials. Let's say we are a leading supplier, and let's say the final key message is we see us as a single point of responsibility, so to speak. We have the products and systems available, including, let's say, all services, and a design team, a lab for testing facilities. We have the installation know-how in-house. We can offer training or supervising of sites. So, and with this, I would like to say thank you for your kind invitation, and you can see here, let's say, the companies that we worked with, let's say, in the past 20 years. Thank you.
Yep, thank you for your attention, and we would like to invite the next speaker over. Jennifer Biddlecombe, please come to the stage. turn on the microphone. Yeah, the button, yeah.
Okay. Good afternoon, everyone. I'll apologise in advance. I have a terrible cough, so it was a present from my son as I left, so apologies in advance for any coughing during this presentation. Thank you for that last presentation. That was really interesting. I think I'm going to go right back to the other end of the mining life cycle and start talking about Krux Analytics, which actually focuses on drilling data, so at the very beginning of the process. So there's been quite a lot of discussion today about the importance of sustainability within our industry, and I think we all agree that every part of our industry needs to reduce our impact and needs to reduce costs. But at Krux, we believe that this really starts with the drilling data. Oh. There we go. Is that working? There we go. So let's return to the beginning. And for many of us, we started with our drilling data given to us on paper. Or if you're lucky like me, it also got given to you on napkins or pieces of broken core boxes. But this data is now normally digitized and entered into an Excel spreadsheet or a different type of database. But what we find is that with these basic digitized systems, there are often common issues for both the drill team and for the mining companies. Mistakes still slip through the cracks, which causes financial issues for both parties. Information can often be delayed, misinterpreted. There's time inefficiencies trying to validate that data. Digital data is often not clean, and data from the various teams and sources is often not comparable. For stakeholders who actually aren't at the drill site on a regular basis, there's little to no insight available for the data actually captured. So the first step to optimization is normalizing that data. If we can build a model that's actually based on normalized data that has been standardized from that very beginning stage, we can now start to draw true insights. And we can start comparing apples to apples. We can start developing analytics, and we can start being able to make decisions from it. So this certainly isn't a new concept. We already take great care to standardize our assay data, look after our financial data. But the true value of drilling data, the information that's coming directly from the rig, has not always been realized. Oh, this way? There we go. So, there we go. Oh, apologies. There we go. So we can use the drilling data for a lot more than simply determining how many meters we've drilled that day or how we can help invoicing. From standardizing that data, we can provide both the drilling and the mining teams with key analytics that they need to optimize their program. The data correlated directly from the timesheets, plots, and surveys and rig instrumentation allows you to track your drilling progress. If we have a look at the top, we can actually see the rate of penetration. And below, we've actually got our integration into the Imago system. We can start to correlate drilling rates with the actual ground conditions. Why did my penetration rate increase? How did this affect the cost of the hole? Are your holes still on target? Do you need to adjust? Are your drill programs still on budget? We can understand the reasons a lot better for standby and how to reduce them by actually categorizing them correctly. By standardizing all of this data, we're actually able to compare teams, rigs, sites, and start to identify the most optimal configurations and plans and reduce costs to actually achieve the maximum number of meters. Okay, so I'd like to show you a quick case study. And this was completed last year, but we presented it at the IMDEX Symposium, which was in January in Vancouver. And this was presented by our CEO, Jody Conrad, and Patricia Frisch from Barrick, who actually implemented Krux at several sites. So Barrick were looking to expand the life of one of their mines in South America. They were looking to expand several hundred meters at depth. However, what they were finding was that there was a really high variability in their F1 reconciliation, so between that long-term model and the production model. And there was big gaps in their drilling knowledge and drilling density as well. So they developed a 2-year drill program, which was over 125,000 meters, 4 contractors, 28 rigs, sorry. When they initially started, the mining teams found it really difficult to actually track the progress of the project. The drilling was really slow, but they couldn't understand why, and they were getting lots of different reasons for that slow drilling rates. So they implemented Krux in mid-2022, and we uploaded some historical data as well. So, we can see Q2 of 2022, and uploaded some historical data. And they were looking to answer some key questions. Why is the drilling so slow? Are we on track against our budget? And can we actually get the meters in the next couple of years to make the decisions for our expansion? So the first thing that they actually noticed right away, by being actually able to see the direct costs associated with all of the different activities, was that they were quickly able to identify invoicing errors that were affecting both themselves and all of the drilling companies that were working for them. Thousands of dollars on either side of errors were occurring. By seeing all of the data across multiple teams and rigs, they were actually able to identify really simple changes that could be acted on very quickly. The most productive rigs were able to be quickly identified and could be scheduled for those really deep holes. Inconsistencies with reporting suddenly became quite visible, such as weather delays. So one company, for example, would say they had a 2-hour weather delay, another would say 6. Which one was the real? By aligning with the dispatch data, they were able to identify what was true and what wasn't. And their mining team were particularly interested in being able to identify the changes that they specifically could make, not having even to rely on the drilling teams for that. So looking at standby, one company had significantly more standby than another. Why? They realized that the teardown of the type of rig that they were using and the weather shelter that they were using was taking up to 12 hours to get in and out of the way for blasting. So the first step that Barrick took to improve this issue was, number 1, communication between the blasting teams and the drill teams, and actually beginning to sequence their blasting and drilling teams. This immediately reduced the standby time. The second step they took was optimizing the rig types with relation to the blast zone. So those rigs that took a lot longer to assemble and pull down again, they moved them away into the brownfield sites, and those more agile rigs that were on the skids, they brought them into that closer to the blast zone. They were able to optimize their own teams with regards to prepping of pads, surveys, staked, water trucks, just by being able to see the reasons for that standby. Analyzing data across all of the drill teams allowed them to identify a great threshold of hole conditioning. That sweet spot between not losing the hole and achieving meters. So if you're not doing enough, you're going to lose the hole, but if you do too much, effectively you're just wasting time and you're not adding any value. So by identifying that sweet spot, they could actually communicate how much hole conditioning they were expecting within a certain area, within a certain rock type, so that they could optimize across the teams. This was especially useful for new drill teams who came onto the project. By optimizing, they were able to dramatically reduce the cost per meter, which is shown here in brown over the... shown in brown, as you can see. and increase the number of meters between about 20 to 40% at this project. Standby was reduced by over 20%, and the total downtime was reduced from 9 to 6%. As well as this, consumables were able to be reduced. Fuel, fluid, wastage, all considerably affected. By incentivizing the drillers correctly, Barrick were actually able to achieve more meters per shift, meaning that the drill teams were really, really happy, and so were Barrick. So they implemented again at Site B, and again we were able to quickly identify the changes that needed to be made. But this time we were able to do it a lot quicker. Within 2 quarters we were able to identify the changes that needed to be made, and therefore increase the number of meters that was able to be achieved and reduce the cost per meter. What was interesting with this one was that they also identified that they actually couldn't achieve the number of meters within the budget and within the time frame. So they had to make quick adjustments and reported that up to management really quickly once Krux was implemented. So what's next for Krux? So far we have been looking at all of the data that has been taken directly off of the daily shift reports, from the timesheets and from survey data. But the next step for Krux is actually being able to take data directly off of the drill rigs. So we're going to be taking real-time data, pressure, water flow, head position. It can all be recorded. And this data can then be used to calculate critical parameters such as depth, differential pressure, rate of penetration. By correlating all of this data back to depth and time, we can quickly see how these factors are related to other tracked activities and the drilling environment. And that's really quite exciting for us because it leads to so many more applications. The insights via Krux Stack exceed just drill program optimization and enable true drilling optimization. So assisting future hole planning, predicting drilling requirements, being able to identify when drillers need to adjust their speed, prepare for hole conditioning, and when to request more consumables. Being able to identify the optimal bit types for a certain environment. The data sets can also even be used for training new drill teams as well, even before they get to the rig. It enables us to accurately track ESG metrics at the rig for better performance. And finally, this is what I find quite exciting, how the drill data can actually add to our geological knowledge, correlating the rate of penetration back to the actual geology to support our predictive models. So this is actually what we did with Barrick. We actually correlated the drilling data with some of the proxy geology. So here we're actually looking at the one of the projects. We've got penetration shown down hole, and then we've got silicification is mapped here, so high areas of silicification in brown, lower levels in blue. And if we have a look at some of that hole data, we can see that rate of penetration changing really quickly. These big structures we see in that blue line, really big regional fault structures. You can see the rate of penetration changing very quickly as it drives straight through that fault zone. Hole number 2, it correlates really nicely with that silicification. Again, rate of penetration increasing as soon as you're out of it. And then finally, just very quickly, I'll wrap up. Hole number 3, this was really fun because it didn't correlate at all. So we're showing silicification here. But then when you actually look at the rock type, you can now see how it correlates really well. We've got this brecciated zone, and as it comes out of it, that penetration rate changes. So I'm not suggesting that you can actually build a model from this, a geological model, but it is that extra data set that can really provide additional insights. If you'd like to see the full case study, then please have a look. It's online, and thank you very much for your time.
Следующий спикер.
Our next speaker, we want to invite the next speaker, Amirzhan Tynybayev, who is the sales engineer of Geostein. Good day, dear colleagues. My name is Alexander Barinov. We've changed with Amirzhan. I will be giving the presentation. It would be brief so I will speak more about the commercial part, about money, and all the technical part. If you want to go deeper into details, you can come to our booth, to our desk, and talk to us. So today I would like to speak about the tendencies of mining industries, and I would like to speak about engineering protection. This is what we do, and this is connected with the safety. Well, we all know that nowadays many mining enterprises, many mines or pits, they have already been used, and we are going deeper and deeper under the surface, under the ground. We make our walls better, but all the methods that were used 20, 30 years ago, these methods are already outdated, and they do not give us the results we want to receive. So two main and global challenges that we see nowadays, and these are the challenges for all mining enterprises. So on one hand we see the lack of qualified employees, and on the other side we see more complicated conditions. We see the complication all the time, and of course the shortage of employees is also an important issue. We were speaking today about young generation, new generation, but you know, people from one generation, these new generations, they don't want to work in mining industry, and this is the reason for us to think about automation and to start using some new technologies. So mainly we are working with engineering protection and safeguarding. We work with some specific supports and some specific frames. You know, after explosions in coal mines, the second catastrophic phenomena or process is different types of different types of collapses or rock slides. So this is related to the change of geometry of slopes. And you know, according to the statistics, in 60%, this is statistical data for, actually for post-Soviet territory. So 60% is due to the violation of safety techniques, and 40% is due to their own protection equipment. But usually what we see, they blame people who died in that case, because nobody could come and tell that something was wrong over there. So that's why we see lots of fatalities, and mainly people are reporting that this is due to violation of the safety rules, but probably it's not this way. So, and there are also some large emergencies or some large things that happens, and we understand that these disasters means lots of losses for investors, and they can amount up to 10 millions per day for different types of mines. We can see some direct and indirect consequences connected with some things. Before we had this investment session where we were speaking about attractiveness of investors to Kazakhstan, but again, we also need to discuss the issue connected with the safe working culture. This topic is very important for international investors. So we speak about the loss of materials of inventory. For example, Alrosa case, we don't even know how it might happen, and there are lots of other accompanying issues and problems that would arise in the places where people use old methods. And actually, I'm not saying that all enterprises have these old ways of working, but many enterprises in Central Asia and in Russia, we have it when we have the instruction on some on some equipment, but this is all already outdated. So, what our company suggests, what we suggest, what solution we can suggest for these issues. Well, first of all, as for the employees and the personnel, we propose to develop geotechnical specialists or engineers. There are lots of new curriculums, educational programs in higher educational institutions. But now, if we speak, geotechnical business or the geotechnical activity is the specific science that could help us to understand how we can facilitate the process using modern innovative materials like geosynthetic and some others, so that to improve the quality. So what we see now, this is also a global trend. When mining enterprises, they work at this on the edge, on the margin. Here we need to know three main issues. First, we need to conduct and to have qualitative surveys. It's clear, but in practice we don't see it. In practice you have to work with non-qualitative, with some dispersed data, and it's difficult to make decisions based on them. The second thing is the monitoring. We need to know ahead what might go wrong so that we would be able to react. And the third thing is what our company is doing. We are providing engineering protection measures, we do strengthening or fastening. But we are speaking about quarries. So we do these specific linings and supports, and we do our work when it is needed. But we need to do it based on the result of our monitoring. And it gives a good economic effect, and it allows us to work in a more efficient way. So there are several case studies and several projects where our customers invested in our solutions. So, but using our technologies, using our solutions, they received more productivity and they received higher safety. And their facilities worked without any standby. Actually, I can say that the human life is not an interesting topic for enterprises here in our post-Soviet territory, but our investors, they are more interested in this non-stop work of the quarry, of the mine. Well, here we have different case studies. If you want, you can come and we will tell more details about it. Well, the first project, this is the first project in Kazakhstan. We have been working on this project for already 1 year, and we see high potential in this direction. So where we can use different types of support so that to increase the quality of the rock so that it would be protected. We will be happy to show all our solutions at our stand, and as our conclusions, as my conclusions, I would like to say that all these solutions have to be very well checked, very well tested. They have to be used qualitative and reliable material. We cannot say let's just decrease some coefficients, let's not do nothing, no, let's just use some net so that to protect and to give some support, but it will not work. Usually it does not work, and it might lead to the bad results. So again, we all need to understand that safety is important, and usually the emergencies happen when people try to save on using of qualitative material. Thank you so much for your attention. We'll be happy to see you at our booth, at our stand. Thank you so much. Now we would like to invite the next speaker. Now we invite Denis Narozhnyi, Alpha Safety. Good day, dear colleagues. Thank you. Thank you. I want to thank everyone who is still here and who can listen to us. I am from Alpha Safety Company, and today I want to speak to you about the other areas that you can meet at each of the enterprise is the issue of ventilation, otherwise the ventilation system. So our company is the official distribution of Howden Company, and we are the local partner, and we provide local support to this company. Howden is one of the largest global suppliers of equipment for ventilation. We consider this maybe not like our mission, or maybe like a mission. You know, when we are at such kind of events, we usually speak that it is wrong if you ignore ventilation issue, because ventilation is very important and it impacts the performance and indicators of the enterprise. And I think it's not a new news for you that any enterprise, including underground mine, each enterprise has its own goal, but usually this is productivity or efficiency in broader range, and the second issue is the safety. And I can assure you that ventilation system impacts two of these elements, because here we speak about all the issues about we can speak about energy, we can speak about performance of personnel. What is the main problems now? You know, we have been working in Kazakhstan, not only in Kazakhstan, but all over here. We work for a long time, we communicate with people, and when we start speaking about ventilation, people start saying that ventilation do not participate in the direct process of exploration. But why we need ventilation? Because we are breathing and we need to have air, and it's not enough air under the ground. So that's why we need to make the air inflow to that. And you know, this seems to people like additional cost, and this is the relation of people here. And sometimes, the people forgot to acquire, to purchase a very qualitative ventilation equipment, because they think, but this ventilation is not for exploration, it's for some other goals. And the other thing is that purchase, when we speak about purchasing, the enterprises would rather purchase more serious equipment for drilling or for exploration. But as for ventilation, they prefer to buy the cheapest one. This is a case that we often face. And that's why, I mean, in many places I see that these fans or this ventilation system, people do not pay attention at this ventilation system. They would rather buy cheap equipment than would replace it, rather than buying a very qualitative one for a higher price, probably, that would serve long. And then, you know, people just have different attitude. And the question is how the company monitors that the ventilation is quite well. But they do this inspection according to standard only twice a year. All other time, enterprises do not know if it's good one or not good. For example, let's say we have here the ventilation system, and we don't know how it works. Works it to the good side. You have the air compression inspection, and you kind of understand that yes, you have the necessary indicators, but again, if they're efficient or not, this is a big issue. Or maybe even the equipment might not choose the right one. But ventilation is very important. I will also tell a couple of words about it, because this is also impact the productivity. Well, let us speak about this. So the time of after the explosion works. You know, after explosion works, there are some specific agent and some specific pollutants, and you have to do the ventilation. Again, you can make these processes after explosion quite well. You know, you need to measure measure what is happening in the atmosphere, and you need to send the air flows in a correct way when it's the explosion. The second issue is abilities or workability of the personnel, and we understand that if it's insufficient air amount and if it's increased CO level or some other pollutant amount, of course people would not work well. And of course this here on my slide, this is the last point, but I think it should be the first point or first bullet point. The life and the health of our employees is very important. This is value by itself, but besides it also means some other values. Here we speak about again days when our people ill, or maybe sometimes they have some injuries, or even cases of fatality might happen. So, I mean, I'm not saying that this is negligence. However, we see that people have a specific attitude, maybe not a very good attitude to ventilation system. And if they have this not good attitude, there are lots of risks and lots of losses. First of all, here we speak about energy efficiency. We say that up to 75% from the total consumption of energy is for the ventilation system. Also, you know, in the winter time we have to heat our air, and the number of energy that we use to heat the air depends on the amount of air that comes to the quarry, to the mine. And if we know that it is not optimized, then it means it is just waste of the energy use. Then, again, we need to have enough amount of air, but still in some places we have the sites where it's difficult to breathe. Like in the mine, you might have had this situation of encountered, right? When you are underground and everything's okay, but then you would come to some point where you cannot breathe, so you start, the tears start going out of your eyes. This is all due to the insufficient ventilation system, and of course the absence of plans. Sometimes we do not know how to plan it, how to organize the air inflow so that it will be efficient and safe. And you know, sometimes people use some unusual method and not according to standards. So they put the air pipeline and ventilation system in a wrong way, and sometimes we have to explain people how to do it. So Howden has a specific approach to solution of this problem. We have EMEA. This is Integrated Solutions for Ventilation. So first of all, we provide the equipment itself, then we provide software that helps us to plan, to control, and service or maintenance. It's not only the repair of equipment, but here we also provide technical support in ventilation system planning. Next, I will show you our products. I will try not to speak about products, but I would like to tell about opportunities that might arise with the use of this equipment. So this is the ventilator of the main ventilation. So this is the equipment that has the long life service time, and here you can see the parameters, and here we can provide the maximum work capacity. So we understand that this system is a very critical system, and if you use it right, you can even save energy consumption. Then we have some local scale ventilation system of fans. They're reliable ones, and you can order them easily, you can install them easily. So this is the equipment that is quite easy for our client to use, and he or the clients could use them on their own.
Air heating, there are different variables. If you have access to gas, you can have direct heating. When air goes through flame, and thus you eliminate the need for all heating infrastructure. Efficiency goes up, consumption goes down, less environmental impact. We've seen this work in Kazakhstan, also in Russia. Air cooling, well, not something that's done in Kazakhstan. But I know at least 2 or 3 enterprises where temperatures can get as high as 60 degrees. Research has shown that when temperature is above 30 degrees, your efficiency goes down rapidly, plummets. So human output is 50% lower at 40 degrees than at 25, for instance. People will say it's too costly to do cooling, but if your output increased 2 times, maybe it's not that costly. What do you think? Now the software. You need to do design properly, to manage it properly, and that usually requires using software which would enable you how to manage it prior to construction and to select the right fans and develop your mines properly. The most interesting thing is what to do next once we have optimized everything and installed everything. How do we manage ventilation? So our system is called vent seam control. And this system means that you can use your 3D model and to install fans in it to see how it would work. Also, you can collect data from sensors. For instance, you see that a vehicle goes in, and based on its engine volume, you can understand how much air you need to pump in. So you will have software that would be able to manage the fans, and you could save up to 50% of energy. So if it is 5 cents per kilowatt hour, Canada, you can see that it is comparable to what we have in Kazakhstan. It enables them to save up to 4 to 5 million. So you install it, you break even in half a year. That does it for my presentation. Colleagues, I would like to give the floor to the last speaker, Oleg Chernyshov. Good evening. Here's our company, Master DETRA, joint venture between DETRA and Master Drilling. Master Drilling is one of the largest companies that does drilling and construction of mine supports, has many records in that area. DETRA, the Russian company, a lot of mining experience and is seen as a contractor, has modern fleet of vehicles for underground and surface works. Our company has implemented 4 projects in a variety of conditions, geologically and geographically. Kolsky Peninsula, Urals, Chukotka, and the drilling we do is usually 20% cheaper than it would be otherwise. Our rates are 3 or 4 times higher, our efficiency is 50% higher, and most importantly, there are no safety concerns because there are no people involved. Here you can see how drilling is done. First you drill a pilot hole, then you use an under-reamer. Our equipment, the equipment that was used at different sites. These are photographs from the sites. An example from Severny site. We were contracted by Norilsky Nickel. We drilled down to 580 meters. Deviation was 0.42%, and we got to do under-reaming to 2.4 meters. Another one, Mayskoye site. There we implemented 3 projects in the period 2022-2024. There were some issues to address because logistically it's quite difficult to get there. Also, this place is difficult to get access to. The weather conditions are rather harsh. This is permanently frozen rock, and the deposits themselves were quite difficult to work on, but all in all the key thing was the trajectory was very difficult for us. It was difficult to find the right angle. So what we needed to do is to build 3 stowing holes at an angle of 68 degrees. 2 meters was distance between each 2 of those. Deviation was less than 1%. A total of 648 meters were drilled. This is the rig we used. Here we were able to have the necessary precision. Then we did piping. We had to use an unorthodox approach. It was bottom up rather than top down. So slowly but surely we would do installation. And then this is how we built a case for the well. Another stage that we did, we drilled 2 holes. Those were vent raises. Total number of meters drilled was 430. We were 40 days, finished 48 days ahead of schedule. We hit several personal records. The average rate was 26 meters per day, and under reaming was 14 meters a day. Here you can see the key stages of the work we did. First is we need to be precise and getting the pilot hole to the chamber. The second one is preparation. Third one is end result. The maximum depth was 252 meters. The next one, also at Mayskoye site. For Russia, it was something new. We were the first to have done it. We did remote shotcreting. It was fully automated. All parameters were controlled by the robot itself. This method is used for all kinds of vertical holes, so this will be sprayed by a robot. You can see how it's done. In our case it was a little bit different, but the principles remain the same. So you send a robot down, and then it will be going top to bottom, spraying concrete, and then it will go up for maintenance when necessary. This is the equipment that was used, the frame, the dry shotcrete unit, compressor, and also the interface which enables the operator to see what's going on. And so all in all, it's fully automated and it is being recorded, which means you are able to do scanning prior to shotcreting and after. Here's the robot itself, its assembly, and this is when it is ready for descent. So it is about to go down and to spray concrete, then it will go up for maintenance. So it was the first time ever something like that been done in Russia. The total length, it was 400 meters. Another thing we can do is to use a rotor-based controlled system. Using it, enable to do to adjust drilling trajectory online. This is necessary when precision is paramount. Deviation needs to be as low as possible. Another one, reverse circulation drilling. This method can be used when you have no access to the pit bottom, so we will be using double pipes for drilling, with the drilling rod rotating, varying in diameter from 800 millimeters to 10 meters. And this is how we create a vertical shaft where piping can be placed if necessary. And master drilling have been able to get rates as high as 20 meters a day. So no personnel is required to be on site, which enables the necessary level of safety. Thank you for your attention. Would be happy to cooperate. Our booth number is 29. Would be happy to answer any questions you may have. Thank you.